Welcome back. In this module, we're going to look at testing asynchronous events, and we'll be talking about what that entails. Our objective, of course, is to build up your skill level so that as you are developing various forms of black box, and in particular, in this case, scenario-based types of tests, we want to add pretty much a whole nother dimension to that testing, thinking about how do we test how the system ultimately responds from asynchronous events. So what are asynchronous events? Well, they're going to be external events, things that happen in the real world that ultimately are going to correspond to one of the most common would be like errors, air handling, some sort of an error that occurs, or different types of messages between the actor and the system, that pretty much can occur at any point in time. So the way that we attempt to go off and deal with this from a testing perspective is we're going to be using a system engineering technique that's literally been around forever called the use of timelines. Timelines are not very sophisticated, right? A timeline is simply a horizontal line representing time moving from left to right. And typically what we'll end up doing is we'll end up thinking about a use case or a use case scenario. And in our use case scenarios, we're typically talking about inputs, stimuli, and then processing that is taking place across the system. And what we try to do is take these more interesting use case scenarios and then try to identify what some of these major inputs are, or some of the major types of processing are, as they occur in the timeline. Timeline meaning what happens first, what happens second, what happens third, fourth, and so forth. And then what we're going to do is we're going to think in terms of the asynchronous event that can occur at any point in time and kind of walk along this timeline, kind of doing a what-if type of scenario. What if this asynchronous event occurs here? What if it occurs here? What if it occurs here, 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 and so forth? So ultimately, as we walk along this timeline, each one of these points can ultimately become a test case. So we've almost added another dimension. The same kinds of tests that we can run, we want to kind of repeat at different points in time. This is best done again with an example. So I'm going to go back to the ATM system that we've used several times already in the class. And in the ATM system, remember we had kind of a normal scenario. And I'm not showing all of the activities in terms of space here, but as part of that normal scenario, a customer was going in and inserting a card. The system did validation and so forth and entered in a PIN. And at some point in time, the customer would request a withdrawal, and then the system would verify that there was enough money and so forth. And then at some point in time, the system would update and debit the account. And then at some point in time later, it would dispense the cash. And at some point in time, the customer would take the cash. All right? So I've taken a typical use case scenario, laid it out on a timeline. And now the interesting asynchronous event that I want to consider at various points in time is something that actually happened to me once. Power failure. Power failure. So ATMs are connected obviously to power sources. And what we're going to do is kind of walk this timeline thinking about what would the system do if a power failure occurs at different points in time during execution of this use case scenario. So let's consider for a moment point one. Maybe this is the simpler one. You're basically, an ATM system has lost its power. What happens at that point in time? Well, if you walk up to this ATM, if it doesn't have its power, it's probably going to look dead. Okay, so nothing's probably going to happen. You're not going to be able to, probably couldn't physically insert your card, or it won't take your card. There's nothing that can happen. So it's pretty straightforward. The one that's a little bit more interesting might be number two. This is the point in time where you have put your card into the system, but you have not really requested a withdrawal. All you did is maybe entered in your PIN and entered your PIN, but before you had a chance to do a withdrawal, the system basically loses power. What should the system do? Now we can look at it from obviously a lot of different perspectives, from the bank's perspective, from the customer perspective. Clearly from a customer perspective, the most important thing the customer wants is, please give me my card back, okay? I put in my card. I'm assuming we actually have something that inserts the card. If it loses power, I don't want to walk away without my card. And furthermore, when power comes back, 1 hour later, next day later, I don't want somebody to walk off with my card who happens to be by the machine. Now, another important question here is, the use of these timelines. I mentioned to you that this was actually a system engineering technique. We know that we want to begin testing early. And actually, the best time for testers to be involved with system engineers is by creating these timelines. If the system engineers have not done them already, then maybe when a tester is participating in a requirements review with the system engineer, the tester can go up to the whiteboard, draw a timeline, and start asking some interesting questions, like what should the system do at point 2? So remember, verification and validation. The use of these timelines is a very powerful validation technique. It's helping us identify missing requirements. So let's jump forward here for a moment to point 4, another very interesting point that actually happened to me. All right, this is the point where I had put in my card, I had entered my PIN, I had entered that I wanted to withdraw $200 from my checking account. I assume the system had probably gone through the activity of updating the account, and just about the time, right, as the machine is starting to kick a little bit, it loses power, there's some sort of a failure, and I never got my cash, okay? What would you want the system to do? What would you want it to do? That's the validation question. Well, certainly what I would have wanted it to do was, please give me my card back, and please don't take the $200 out of my account, all right, because I never got my money. In practice, how would it be implemented? Okay, the way that would require, okay, if you're actually going to implement something like that, and you think about it, right, with a kind of a cloud-based kind of a system, client-server kind of system, what would you want? Where the bank is the server at this point in time, what you would be hoping, the way the implementation would occur, is some sort of a handshaking, meaning that the transaction is not completely closed. There's no actual updating of the account until there's verification from the ATM machine that it has successfully dispensed the cash. Well, that actually didn't happen in my case. Eventually I got my money back, but it was more of a few weeks later after they serviced the machine, they determined that funds weren't given. But regardless, okay, there are requirements that need to be addressed. You need to think about what the system should do at each and every point in time. That's the system engineering question. That's the requirements question. The testing question is just pretty simple, right? Each of these particular points in time, what you are going to do is basically introduce the asynchronous event. In this case, you're introducing the error. Or in other cases, you're sending a message. It could be an interrupt. Whatever it is that's occurring, you want to try. Each one of these points along the bottom here is something that you need to try as a test case. So what we're really doing is strengthening our test cases in the system. Okay, so in summary, there's nothing particularly complex about testing asynchronous events. The standard technique is going to be to create a timeline. Hopefully you're doing that with system engineers while the requirements are being developed. So you're hoping to validate the requirements, you're looking for missing requirements, you're trying to make sure things are complete. And then ultimately during the testing itself, you really want to walk that timeline by creating the test cases for each of those different asynchronous events. Thank you.